You'd like to take the integral of 1 over x square root x squared plus x minus 1. Notice that you might be tempted to use the arcsecant, right? But you would fail because there's that x there that is not letting you do that substitution, right? So if it were x squared minus 1, then the arcsecant would take place. But there's that x there, so you can't use that result. So you have to use another substitution. And notice that x squared plus x minus 1 cannot be factored, right? And how do I know that? Check the discriminant. The discriminant is b squared minus 4ac. b is 1, and a is 1, and c is negative 1. Right? B squared minus 4ac would be 1 squared plus 4, right? So that would be radical 5. If there's a radical 5, this cannot be factored using integers, right? Or whole numbers, right? So this cannot be factored using whole numbers, so we have to use another substitution. So the substitution is going to be for this trinomial, x squared plus x minus 1 is going to be u, that's the new variable, minus x squared, right? That's the substitution that you should look for whenever you have a trinomial inside the root and it cannot be factored, right? This is going to be the substitution. So now x squared plus x minus 1 is equal to u squared minus 2ux plus x squared. Okay, so now you need to isolate your x and solve in terms of u, right? So notice that the x squared are gone, the x squared part, right? Because they both subtract from each other, they give you 0, right? But you have then x plus 2ux is equal to u squared plus 1. Okay, so then you can factor this out, the x, and you would get 1 plus 2u is equal to u squared plus 1. So x is going to be in terms of u squared plus 1 divided by 1 plus 2u. So bingo, now you can find the dx, right, the derivative, because you need that for the substitution. So the dx using the quotient rule is going to be 2u times the untouched, the bottom, minus the derivative of this, and this is untouched, the top is untouched, divided by the denominator squared, like that. So this simplifies as 2u squared plus 2u minus 2 divided by 1 plus 2u squared. So as a result, you're ready to, there's one more thing that you need to do. You need to, well, we already did it actually, right? So we solved for x, we need that x, and we solved for the dx, which was here, and then we solved for this trinomial under the square root, right? We know that this is the value. But there's one more thing you need to do. Notice that there's u minus x for this trinomial, and you need to have x in terms of u. So u minus x, we need that, right? U minus x is equal to u minus, what was the x value? This part, right? U squared plus 1 over 1 plus 2u. Right, so this is going to be what? This is going to be u plus 2u squared minus u squared minus 1 plus 2u. So that is equal to u squared plus u minus 1 over 1 plus 2u. Right, and we should not forget the du part here for the dx, right? Okay, so now you have solved for everything here. You have solved for u minus x, for the dx, excuse me, for the x, and the trinomial. Okay, so let's see. So now we're gonna have, let's separate this part because we're not gonna need it anymore. I mean, this is not work, this is just substitutions. So the dx is gonna be, let's factor out the 2, right? There's a 2 in each of the terms here, right? So we can factored out. So u squared plus u minus 1 over 1 plus 2u squared, right? This is just the dx part. Now 1 over x, what was the x? Right, let's put 1 over x, the next thing. The x was a fraction, but since we have the x on the bottom, we will flip this fraction, right? So we will have this as the top, 1 plus 2u over u squared plus 1. And then one more thing remaining, 1 over the square rooted trinomial. And the square rooted trinomial is exactly u minus x, right? Because if you square root this, you will get the square root of this trinomial, right? Which is that. And that we already solved everything in terms of u, right? So we have it ready. So once again, since you're dividing by this, if you're dividing, right, by this fraction, you will flip this fraction, right? So you will put 1 plus 2u here, and then this top will be the bottom, u squared plus u minus 1. And now we're ready to put the du there finally, right? So now notice that there's lots of things that you can cancel. U squared plus u minus 1. 1 plus 2u is going to be squared because it multiplies itself, but there is a 1 plus 2u squared in there, right? So you can cancel those guys out. So now you have a much simpler integral as a result. So you have 1 over u squared plus 1 du. So that is familiar, right? You know that the antiderivative of this is the arctangent. So arctangent to arctangent of u plus a constant. So now you have to put everything back in terms of the original variable. So notice that u minus x was equal to the square root of this, x squared plus x minus 1. So that u can be expressed in terms of x only by adding x on both sides. Right, so that's going to be square root of x squared plus x minus 1 plus x. So there you go. So now you can express your result here. So 2 arctangent of square root of x squared plus x minus 1 plus x, parentheses closed, plus a constant. So this is your final antiderivative. Hope this was a lot of fun. Thanks for watching. See you in the next video.